Okay, it looks like it works. Very good. My name is Larry Whited. My call sign is AB4NX, and I am the AEC for training for Gwinnett ARES. I am also the Georgia Section Technical Coordinator. So this presentation was designed to be given at the ARES meeting in January, which did not happen. So I'm giving it here with a little slant on the Gwinnett ARES side here. Okay, so digital communications ham-rated for the 21st century. And the reason I chose this particular approach is that our offering to our served agencies, and therefore what we have to offer in terms of emergency communications vis-a-vis Part 97, really has changed over time. What our served agencies need from us is a lot different than it was 50 years ago or even 20. So I just want to start out by just taking a quick look at what it is that we do as providers, our volunteer communicators. So our role in this arena is to provide communication naturally. What we need to do is to provide a professional level quality of service that will match what we what we expect from our served agencies as the public. When we are volunteering for public service in the capacity as a partner with them, the public expects to see from us the same thing, the same level of quality and commitment that they do from the people who are being paid. So just because it's a volunteer job does not mean that we have to give it our all when they're there, when we're at the site, and that we also have to dress appropriately, act appropriately, and remember that we are people who assist and do that with humility and do it honorably. We should kind of shift our focus away from the idea that we have some solution that we can give that will be a drop-in solution for emergencies and loss of utilities and all that. We rather should focus on what we do as partners to do it with skill, accuracy, and do it without self-importance. We got to remember that we're on a team and that we are service-oriented. We agree that our served agencies are public servants, and therefore when we are in their premises offering services, we have that same bond with the public. We need to realize that the satisfaction comes from doing a very good job, and that our motives need to come from a service base. So what role does amateur radio play in emergency? And I think one of the most important things that we can look at is what we are not. In this day and time with satellite uplinks, trunking radio systems, and all sorts of stuff, I am a ComL and a ComT with the state of Georgia, and I can tell you that I do not know half of what they use. I understand the basic stuff and I know how to fix stuff, but it is a very complicated world we live in. John Davis can tell you that. He works for EOC there, and it is a mightily complex. So we cannot hope to replace all that infrastructure with our stuff. But what we can do is get them by that first 12 to 24 hours. We are not RADOs. There are people that think that that title sounds like a good thing to say. It is not. We fit into the technical specialists, not to be confused with the ARRL role as technical specialist, which is a credentialed section And I'd like to introduce today Mark Bell, our training and development DEC, is now a technical specialist with a digital training emphasis. So these are, this technical specialist is a NBEMS moniker, and it is used to, and in my next slide, I'll be showing you how that fits in. So we are here to assist, and if we need to, we're going to pick up their radio or whatever it takes, or we're there to make it happen in an emergency. So just to understand NBEMS, the NBEMS structure there, as a group, communicators are a strike force in general, unless they're just one individual. But if there's a group of radio operators, they are a strike force. So why is digital so important in the 21st century? Here are some of the really key aspects that did not exist when voice radio. When, for instance, when a emergency operations vehicle comes into an emergency, for instance, the cop cars, they have a full data communications in their vehicle. They do not have to do a lot of their work by voice. They don't have enough airtime on the radio. It's a shared environment, and they don't have time to send all the data. So my premise here is that digital modes mimic what our served agencies require, and therefore they become more and more important in providing the relevance for us in the 21st century. And public service is the key to keeping our bands and our privileges, according to Part 97. And that's why the ARRL is so assiduous about maintaining the records and providing those hours of service. We have probably multiple millions, maybe billions of dollars worth of band that could be used for something else. So we should really jealously guard that and realize that part of that commitment is that part of amateur radio needs to provide the service that is necessary. Not every ham has to do it, but it is a very important function for amateur radio in the 21st century. Digital modes in many cases allow for automated error correction. These are some of the things that really make digital communications important in the 21st century. So digital modes allow for large data sets to be sent with accuracy, pictures, spreadsheets, and especially those ICS forms that are the same forms that are used by our service agencies and that we can transmit and print and use for record keeping. This is so important, for instance, with things like Winlink. Winlink ICS 309 is automatically generated. Digital modes allow for the served agencies to use the same forms that we have in our broad forms library on both Winlink and on FLDigi, the NBEMS suite of. There's an extensive catalog of forms available. And also digital modes move a lot of traffic that can provide us more time to do critical tasks. So, which is staying in touch and being alert for changes in the operational plan. So Georgia ARES has chosen 3 modes with the following precedents: Winlink with Winlink Express and the standard templates message library, FLDigi and the NBEMS suite of forms, and DRATS. DRATS is under a lot of revision right now, so it is very helpful as a background apps on a kind of a chat sheet. but it has its drawbacks right now because some of its functionality is less than optimal right now, but we are hopeful that small volunteer team that's working on that can bring it up to date and help us. So here's the key point. Understanding how and when these modes are most optimally used is our mission as expert communicators. And the proper use of forms with the attention to detail is the goal of proficiency standards, which is what Mark has introduced for the state of Georgia, is a set of standards for operation that will put us on par with our partners and make us capable of operating in emergency situations, both in the with our served agencies in terms of government operations, and also with the Red Cross, because we need to help them as well. So just a quick overview of what is Winlink. And I know most people probably in this audience know exactly what it is, but I just wanted to point out the architecture. It's a network of amateur radio authorized government licensed stations that provides worldwide radio email using radio pathways where the internet is not present. Now, here's some of the benefits of Winlink. It allows for time shifting. In other words, you send the message and the person, you know, if you're like on FLDigi or you're talking to them, if somebody's not listening, they're not going to get it. If somebody's not tuned to the frequency with FLDigi, they won't get the message. So it allows the store and forward mode to be used, which is the same mode that all emails are used on the World Wide Web. So it's very much on the backside, very much like an email system. The difference, of course, with Winlink is it has a radio side where you can access the World Wide Web, and we're going to look at the architecture more specifically. And of course, Winlink Express is the program that we now use. And I just wanted to, some people are into, you know, the Linux modes, and I most certainly am, and I would be very happy if Winlink Express would be cross-platform developed, but Pat Winlink is available for Linux and Raspbian-based systems, but it unfortunately lacks a lot of the features that are necessary for operation in an emergency environment. So Winlink is a global system, not a radio mode. So it's very important to understand that it is a connected system with many modes of access on the backside. The cloud you could think of like the big email server in the sky that we send our emails through. It is there accepting our requests to send or receive traffic locally at the remote radio or remote servers, the RMS. And each gateway is called an RMS. So you dial in, you get on your radio and you access the RMS server, and thereby you can access the internet and the facilities of this very effective system. So a Winlink architecture, this is a busy little thing, but it just represents your interface with the internet via your radio. And I'm going to go through the various ways you can get there. There are several radio system, shall we say, protocols whereby you can access this system. The back side of this is Amazon Web Services, and it used to be 7 distinct servers. Now it is integrated in the distributed services of the Amazon Web Service. There is a backhaul server that's there in case there's a failure with AWS. So another method that can be used with Winlink is peer-to-peer. Advantages of peer-to-peer, no RM, I'm sorry, go ahead, Mark. Can you hear me? Mark. Okay, I thought I heard Mark.
No, we didn't.
Okay, I'm sorry. Advantages of the peer-to-peer system are that you don't need a gateway, that you can talk between 2 radios, can be used with multiple radio modes, even Telnet can be used for peer-to-peer. Packet can be used, VARA HF and VARA FM and RDOP and PACTOR, as well as RDIN, which is uses 2.4 gig of Wi-Fi with special antennas, and can and also 5 gig, and can cover a wide area using its distributed mesh network capabilities. Peer-to-peer can be, you can pick a frequency, the gateways, there's only so many of them, and it can be very busy and hard to get into. And of course, when grids are down, there aren't any gateway connections to the internet unless you have some kind of a special backhaul to an internet in another location. And that's the whole purpose of the radio access system, is to reach out to where there is internet. So anyway, with peer-to-peer, time synchronization absolutely has to be there. You can't talk to somebody if they're not on the air, obviously. But you can set up a radio a station in peer-to-peer and be prepared to receive messages, although the FCC would want you to maintain a watch on that. So here's a really important, when you get into Winlink, you're going to understand that any peer-to-peer message has to be specifically addressed as peer-to-peer, and we will cover that in our Winlink training, but it absolutely has to be posted that way in the outbox. It will never go. So common radio modes are shared. I think we mentioned this already: packet radio, RDOP, VARA, VARA FM, mesh network, and PACTOR is one of the original methods of doing this on HF. It's a special modem made in Germany by a company called SCS, and it is rather pricey, and we're very happy that VARA HF and VARA FM have come and basically obviated the need for that kind of money to be spent. It's real important to understand when you're setting up your radio the concept of the virtual TNC. A TNC, a terminal node controller, is a device that generates sound and manages connections. So keep that in mind. It's a sound generator. It's basically a modem and also a traffic manager. And a virtual TNC is a modem and a traffic manager as well, only it's done in software. And we have several examples of that, like the sound modem program, UZ7HO, we can use with the signal link and do packet. And that particular virtual TNC generates the varied sounds that are separated and generates, and it also manages the packet flow. A hardware TNC takes care of sound generation transparently, so all you have to do is hook up to it and it kind of handles the traffic itself. So Winlink Express, as a piece of software, manages the high-level flow of traffic and manages the generation of emails and a lot of the high-level connection commands that you want to do. But under each mode, there is a virtual TNC or a real TNC, depending on the mode, and that's where the business is going on. So I'm going to have to speed it up here a little bit because we're running a little bit short on time. Packet, I think most people are familiar with. It's been around forever. It's not as fast as we would like, even at 9,600 bauds, that's much better, but we kind of depend on it as our robust get-through thing when nothing else works. Nowadays, we have some really exciting new technology coming along that's going to improve the throughput and make it easier for us to move things like pictures and spreadsheets and stuff like that. Spreadsheet data. We don't move the actual material. What we do with Winlink is that we extract that data and attach it and send it along its merry way. it's a good idea not to use packet and VARA on the same channel. They don't play well together. Now, RDOF is Amateur Radio Digital Open Protocol specification, and that I'm not going to go into that a whole lot. It is a open source thing that was developed by the Winlink development team, and it is fast kind of losing popularity because it's much slower than VARA HF and VARA FM particularly. RDOF will work on 2 meters, by the way. It'll work anywhere, but we don't see that done that often. So VARA, that's a strange name, and nobody really knows exactly where it came from. I made a little humor here, but anyway, it's a Spanish word, and Jose, the author of the method, knows why it is used, and the rest of us are not quite sure. So VARA is a weak signal mode, and this is a little bit of technology here. I try not to get into the weeds too bad, but it's a high performance HF and FM based OFDM, orthogonal frequency domain modulation, and I'll kind of just use visual methods to get this across. It's a vector-based channel packing strategy. And VARA modems brings to the state-of-the-art military-grade technology to new and existing HF data. OFDM, for instance, is used in the latest Wi-Fi G6. So it is very efficient in moving a tremendous amount of data without actually having a lot of signal variation. So I'm going to move right past this. It is really almost as good as PACTOR. PACTOR will operate below the noise level. VARA kind of needs to be at least at the noise level. So a little diagram of OFDM there, and I'm going to show you another one that's really a lot better at describing. This is channel packing at its best here. You'll see all these little, and this is a vector scheme where so many things can be packed in one very small audio channel. So just a little example of, now this was done from my radio, and I live in a hole, and you can see how messy that signal is, but that thing was still working surprisingly well. So I just want to put in a plug for the paid VARA use. There's an unpaid version, which is nothing but a trial version. It's meant to be used to see if you like the way it works and help you understand how it works, but it is extremely slowed down. It's crippled in terms of it has none of the gear shifting that goes on in the paid version. It is slower than RDOF, and I highly recommend that you spend the money. $69 to get this 21st century technology is just a bargain. When you think of the cost of, I have a PACTOR 4 modem in my Go kit that cost $1,800. Let me tell you, $69 is not bad for what you get. Here's a little comparison between the throughput. You get, we did a VARA paid version. This particular file was a 20K picture file, which is about the limit of what you should send on HF. It took 2 minutes. We did RDOF, it was about 4 minutes. The unpaid version actually failed after 30 minutes. So it is just simply not designed to move data. It's only designed to use text and very small files. Okay, so how in the world can we get the kind of throughput that we get and comply with the symbol rate requirements of the FCC? That's almost hard to understand. Here's what's going on. We have all these carriers that are vectored in. The symbol rate remains 37.5, which is the legal requirement. Look at the gear shifting that's going on here. We start out at a data rate in the tens, and we work our way up. You can hear this going on with VARA, and it shifts according to the conditions, and we find ourselves running 56 5,629 bytes per minute. That is comparable with PACTOR 3. So it is phenomenally fast and very efficient. So here's just a little example, and this is old. It's actually, I am getting as high as 15 BPS, 15,000 BPS under ideal circumstances and in the experiments that I've done. Packet runs 1200, 9600. 9600 baud is pretty fast. It's pretty acceptable. VARA FM is listed as 25,000. I have gotten as high as 56,000. In fact, in my laboratory setup here in the house using attenuated antennas, I got 128K throughput. So it has been improved about 4 times in the last 2 years with unbelievably large improvements in the throughput. So here's the advice: if you refuse to pay the money, please use RDOF. I run several gateways, and my HF gateway, it's just absolutely painful to watch people on there. It takes forever. So please just use RDOF. It's a lot faster and it works quite well. So I'm going to move on to VARA FM. It's kind of a steroid. It's really a step above, and I'm not going to spend a lot of time here, but I can tell you the optimal sound cards are the DRA 50 sound cards. But I'm telling you, any signal link that's a modern design will work just fine. You can use signal links, time waves, devices like the PK232, and any one of those work fine. So here's a picture that I sent across. This is a 60 kilobaud picture, and you can see this picture is actual size that came across. My transfer rate is 128,000 baud. It took me it took 28 seconds for this to come across. That is phenomenal. The connection time, there's a lot of overhead in the connection. It took 1.7 minutes. So that's just an example of, in an ideal situation, how, so the recommendation is here. Match the message to the mode. For packet, no pictures. For VARA, 20K is the limit. And when you if you get involved in our Winlink proficiency lessons, self-study lessons, you'll find out how to size pictures using Winlink Express. It's a phenomenal tool. It works extremely fast. You can actually size or shape the area of the picture that is being used. So, and for VARA wide, which we have a station KX4MAT-10 on the mountain, which you can access from Gwinnett County. You get phenomenal throughput, and you can go up to 60 kilobytes. So I'm going to move on really quickly here. Just to review the difference between Winlink, one station communicates with another station, whether that be an RMS gateway or another peer-to-peer station. It is a handshake method. So it is not a broadcast mode. And that's the difference between this and FLDigi. It really is quite a different system, and that's where it gets its accuracy. So let's move on. There are several other versions of Winlink that people don't know about. Winlink is used by shares, a NTIA-based non-FCC government frequency. And also there is a sail mill that's a paid thing. It's totally separate, but using the same technology. And this is an all-volunteer team that works countless hours keeping this system alive. Totally recommend that you make a small contribution and help them out, because what they do is real yeoman service. And there is a program called PAT that will operate on Linux, Mac, and ARM machines. I have it on my Raspberry Pi. I've actually sent Winlink messages. They now have the Winlink forms available for it, but it just doesn't have the capability that we need for public service. Okay, what happens when the internet goes down? Radio only and relay. We have my gateway on the mountain, the AP4NX is a hybrid gateway. It serves as a radio connection point for radios across the country. There is a series of hybrid gateways. There are not that many of them, There's one in Florida. There's one, I don't think Alabama even has one. There's one or two in Tennessee. And these stations have an intelligent piece of software that can route stuff by radio to the point where where the internet is, or even if there is no internet, it can go, if you have registered previously with these radio message servers through a system I will show you shortly, those messages can be forwarded. They can also, my gateway will function without any internet and can be basically be a mailbox that anybody that can reach it can send to the other person, and it'll stay on there until they check in and pick it up. It's a very thin client. Don't expect to be able to move a lot of traffic through it, but it's there. It's kind of the doomsday scenario. So here's how you make sure that you have access to something that's outside your internet zone or another station that is on the radio message server. There is a section called hybrid parameters, and on that setup page that you can go into, and what you see here are what you call message pickup stations, and you can select up to 3. They recommend just 2 because all this data as to your preferences goes and is shared by all these relay stations, so that say you had KX4Z, that's our good friend Dr. Gibby down in Gainesville, and if you put that in and you needed to, and somebody sent you a message, if you checked into KX4Z, you would find your message there, even if there wasn't any internet at all. So that's the beauty of that system. So here's a little quick tips on installation. VARA is a really kind of a messy program because it involves so much of your computer in the process of doing what it does. And there are people on this call that know a whole lot more about this than I do, but I do know that it is very important. VARA and VARA-FM are root directories that you put, or that are automatically get made on your computer when you install them. My recommendation, I found this to always work. Virus programs hate VARA. It does a lot of stuff that heuristically looks like malicious activity. It is not malicious activity. It's just it's engaging sound cards and a lot of the resources that Windows considers more of not for other operators. It looks bad. So what I do is I down this thing and I move the zipped file right into these directories. I make them first, VARA and VARA-FM, and they are all capitalized. I didn't capitalize that first one, it should have been. And you make those in your root directory, and you move the unextracted in there, and you extract them right there. And if you have a virus program, you need to whitelist those directories before you ever do this, and then you guarantee that it'll work. And then you extract the file in those directories, and then you must install them as administrator, as it tells you in the installations. And of course you do say install anyway when the question comes up. So general principles about sound. Think of sound control as a chain of switches and pathways. If when a person first gets started in setting up these virtual TNCs, they get a little confused. They think, maybe that in Winlink Express, that's where you're supposed to set it up. And the fact of the matter is, these virtual TNCs is where you select the sound card you need. So, but in a complicated radio like a 7300, 7100, a 7610, you will find that most radios have to have a certain amount of setup to let it know what sort of data you want to go when you invoke the data mode, which is usually another selection. In other words, there's USB, FM, whatever, all those modes. And one of the other selections on that same in that same area is D or digital or data modes. And so it's USB data, USB D. So you have to hit that switch in order to invoke. But before you set that up, you do have to tell the radio, do I want it to go through the USB channel, or do I want it to go to the back of the radio through one of the ports back there? So just understand that you have to let the radio know what to do with the sound, and then on your computer, you use the virtual TNC to select where you know, which sound card is to be used. And I'm not going to go into all the troubleshooting there. We have an entire lecture on that we're going to be putting out on Gwinnett ARES. You want to adjust for as much a little ALC as possible. VARA works pretty good with to about a third of ALC. I personally run it pretty much with none and just turn the power up, and I usually get anywhere from 30 to 50 watts of output, and it works phenomenally. You don't want to stress out your front end. You can burn out your transistors. You can also create a tremendous amount of distortion. So it's all in getting that sound at the right level to your virtual into your radio, so that the radio likes what it gets. When you see that ALC kick in, that means that the radio is not happy that you're distorting. Okay, so here's a little kind of what a VARA screen HF looks like. You will see on this area over here, there will be bars that come up. What I'm talking about in selecting, this is the setup screen on VARA virtual TNC under sound card settings, and this screen will pop up and you will select the appropriate USB codec, and that's how you do it. Okay, sorry I have to run through this pretty fast, but there's an awful lot to cover. The RDOP setup screen looks a lot like this. It's a special screen, and there is some management of the sound level actually on Winlink Express, because it is a kind of part of Winlink Express, but you still have to invoke the correct sound cards in the virtual TNC box. So here's a few tips. If there's no output on transmit, there is likely no sound getting to your radio. So you need to look down that sound chain, and it can be something as stupid as you look down at your speaker icon on your computer and there's nothing. Charlie, I see you've raised your hand. Would you like to ask a question, sir?
Larry, thank you. Could you go back one screen, please, sir?
Yeah, there you go.
Okay. I'm doing this on my phone. It's very difficult. Okay, thank you so much.
Okay, sure. There's two places to adjust sound levels. The recommended place is actually up here in File on the main TNC control on Winlink Express. You can also adjust it down here, but it's a little flaky. So this one up here is your final adjustment. Okay, so here's some really important principles. If your speaker icon has a slash through it, that'll shut it down right there. That's one place to look. The other thing is to look through the sound chain and make sure that you've selected the right sound card in your virtual TNC. And in your radio, many of the more advanced radios have sound levels for USB, sound levels for the accessory port. And so getting that sound right can be very complicated. What you try to do is when you're working with multiple modes, you try very hard to set your sound level so that no changes have to be made on your computer. So that way now I have actually 3 different devices on my radio, and because I have a computer that runs my station and I have everything set up right, I never have to touch a thing. Everything works right out of the box. Unfortunately, when you're in a portable situation, every time you unplug that to USB plug, Windows goes nuts, and it it does a fairly poor job of keeping up with sound cards, I can tell you. And the newer versions of Windows 10 and Windows 11 are even more prone to needing some troubleshooting. I don't have time to go into that, but let me just say this. 50 watts is the most you should ever need. I have put out as much as 100, but I have a 100% duty cycle radio. But on your small radios, 50 watts, do not go above it. You can burn out the front end. Distortion is the enemy of good decoding. Tune your antenna tuner well. You see, I did this in yellow, and that's for a good reason. That is the first step. Get your radio happy. I know you've heard from people that teach antenna theory, and I totally agree with it, that the antenna is only there, the tuner is only there to make the radio happy, and that is totally correct. But let me tell you, with digital modes, your radio has to be happy, because there is so much stress put on that front end that the radio gets very unhappy very quickly. If you're not able to get more than 10 or 15 watts out, you need to check your antenna tuner and hit it twice just to make sure you didn't just long press it and make it go into another mode, like bypass, for instance. So be kind to your final transistors. Stay away from nonlinear output as indicated by higher levels of ALC. And that's where I mentioned that Jose recommends a third. I personally work with almost none, and it works fine, but I have a really powerful audio section in my radio, much as many other people do that have 7610s. Okay, just to let you know what it looks like on the front of a radio, this is an ICOM radio. The other radios all look pretty much the same. On a 7100, which is a very common Go-Kit radio, you'll see one device and you'll push it and you'll see the next one, you'll see power output, and you'll see ALC, and then you'll see comp, and then you'll see SWR. And there's a way to make them all show up at once, and you just press on that screen, long press the screen, and every one of them will come up. Unfortunately, every time you muck with and go back into the menus, that'll be lost. But this is the way you're able to see power output and ALC at the same time. Okay, here's something important for deployment. Grid square is very important when you move from one place to another. Why is that so? Well, there's a few reasons. One, the distance between your radio and the target station is indicated. Two, the selection of the channel selection that you have available changes based on your grid square. And it's based on the distance and the time of day and all that good stuff. So also, for safety reasons, be able to describe, if you've ever been on deployment, you realize that this orientation is extremely important. You really need to be able to describe not only your GPS coordinates, but your cross street and your physical description, because if you need help, if somebody gets sick up there in the death race, we need to know how to describe the people to our responders exactly where we are. So those are two things you need to keep in mind. When you go or you're deploying, preload your available gateways by changing in your setup screen your grid square, so you know what the resources are in the area you're going. Every county should have available radio resources in their SOP, including gateways and digipeaters, so you know in your deployment plan exactly where you need, where to look for your resources. And we're working on that with Georgia ARES, and trust me, we're fine. All those gateways show up on the resources of Winlink, but unfortunately, the digipeaters do not. So that's a big problem, and we're working on it. The Georgia ARES situational awareness map located, there's a link on the Georgia ARES website, and it is a great resource for that as well. So here's how you enter your grid square. You know, on your properties, Winlink properties, your setup page, if you come down here and you change that grid square when you move to another location, it's very important. I had a guy call me or send me an email, actually sent me a Winlink, and he said, you know, I'm located up here in Maryland, and you're located down there in Georgia because it says so, and it's only 100 miles away. And I want you to be aware that there was a problem there. And I said, well, here's the deal. The way this is figured out is your grid square versus my grid square, right? I said, maybe you need to go check your grid square. And sure enough, he said, he sent back kind of a sheepish reply saying, I'm really sorry. I looked in there and my grid square was wrong. So that's an important thing. It brings to you a lot of resources that you need. And so anyway, this is the channel selector that drops down, and you can update it by the internet or by radio. It's very slow by radio. You can click on each one of these columns and arrange by frequency or by grid square. So one of the, it is true that the best stations show up over here in this column, and even for 2 meters. But if you kind of want to look at your grid square, you can find your grid square, and it will give you every one of the best performance of the stations that are closest to you. So it's a really good way. And this is a packet that would be VHF side. And you'll notice that I think I had it set. So you see by mileage, you can kind of figure out whether you might have access to the digifeeder or at least the gateway. Okay, how do you know where you are? Well, there are apps for that. And Hem Square is a great one. It gives you not only the latitude and longitude. There are 2 forms of that. Most of modern programs use the decimal format, and you'll notice that Winlink is very modern in that it uses decimal. Minutes and seconds are used by a lot of legacy agencies like the Coast Guard and in certain other military assets. And you may even find that you need to have that accessible on your for your local responders when you call 911. But usually on your Compass app on your phone, which almost all phones have them, you can change that over from decimal to minutes and seconds. So this is some of the examples of the resources, the apps you can download for both iOS and the other one whose name escapes me. Okay, just a quick rundown of FLDigi. This is a program by by David Fries, W1HKJ. It has a fantastic array of sound card modems. His technology is highly advanced, and he also has a plethora of available forms. Some of the modes, he has almost every conceivable modes like Olivia and all the other ones that are very narrow bandwidths. And by the way, we are looking at using Olivia as a backup for really bad situations when you can't get through. So the nice thing about this is this is a broadcast mode. More than one station can get advisory broadcasts about weather, about changes in frequency, you know, and all sorts of things that the incident commander might want. You know, the radio person who's running the radio command can get out via FLDigi. So it's really good in terms of broadcast. Some of the modes have actual certain amount of error correction. FEC is how they do it, and others not so much. But anyway, just a quick, the forms that are used with that are called NBEMS, and that means narrowband emergency messaging software is what that stands for. It's a rich inventory of forms. Actually, they have many more forms for the ARC, the American Red Cross, than are actually available in Winlink. And these forms, you can strip the data out of them, and this is part of the training in our intermediate levels and advanced levels, is how to strip data out of an NBEMS form and send it via Winlink. And these forms, actually, you can give the forms in a USB device and hand it to your served agency, and they can actually fill, like the Red Cross at the shelter, they can fill out if they have some detailed message that they don't want you to mess up, they can actually fill it out for you, and then you give it back to you, and it can be sent on. So there's no error involved. So it's very flexible. It can be used on HF and repeaters. We do this. We've done this in the past here in Gwinnett County, and it can be done simplex. It's really a truly grid down mode that works fine without any internet. So very useful at disseminating information. Okay, DRATs, I'm going to quickly just mention that again. It uses a system called a ratflector to kind of, it's a chat function, it's a message handling, and it provides some map use and file transfer. Unfortunately, using it on RF, the bandwidth on the older radios is pretty poor. They're better on the newest radios, but it does easily get congested on RF. So you need to, it needs to be used wisely, shall we say. So, and I just wanted to cover what we've been working on for the last year. Mark, I say we, I need to give Mark full credit for this. Digital proficiency. And Georgia ARES seeks to build, and I seek to try to do the same in Gwinnett County, to build a core group of highly competent communications expert. Reliability and core capabilities are goals that we seek to obtain. I just kind of define the word proficiency, a high degree of competence or skill and expertise. So this is a subject for another lecture, because this was going to lead into a talk by Mark about digital proficiency, but I just want to say that the focus of his training program is to familiarize you with the forms, to teach you the discipline it takes to not change data that is given to you by served agencies, to accurately transcribe and to interact with your served agency. So it's written in such a way that it's introduced with a 201, just like it would be in a normal ICS environment. It gives you all the feel and flavor of a served agency operating under the NBEMS protocol. So, and explains in detail how to correctly not screw up the forms and make it work for you. So, and my challenge to Gwinnett ARES is, we have a fairly large group of people. Not that many of them are all that active right now, but I would love for Gwinnett ARES to be the place where we demonstrate how this is done. So I want to kind of identify some of the characteristics of team members in a served agency environment. Team members serve with humility and honor, focus on skill and accuracy rather than self-importance. We need to understand our mission. We're not here for us. We're not here to brag about our capabilities with ham radio. We're here to integrate our capabilities with that of our served agencies. And the goal is to protect and serve for the people of Georgia and Gwinnett County in our case. The motives should be to find satisfaction in knowing that we did a job well. And here's a problem that we run into a lot. People either overcommit and get burned out, or they don't commit enough to actually do a professional job on the job site. We need to thoughtfully balance our commitments to our families. We need, families always come first. We always say that, and if your family needs something, somebody else needs to do the service. But when you do commit, when we do deploy, we are the face of our served agencies. And finally, the lessons learned in this module are choosing the right band and the right mode with skill and proficiency. So you need to use, use DRADs for chat, use FLDigi for broadcast, use Winlink for accuracy and record keeping and all that good stuff. And for contact purposes, you can reach me at the following site. My position with Georgia section is technical coordinator. It is my job to align the resources with the needs in the state of Georgia. And you can also have a Ham Shack hotline number that you can reach me at. Mark Bell is the technical specialist for digital training for Georgian section, and this is his email address. Okay, I'll open up very quickly for questions. We're running pretty late. Anybody have any questions?
Larry, Mark, one comment.
Yes, please.
With respect to what was mentioned a few moments ago about the Winlink proficiency and the Winlink proficiency program, there is now a recording of a session given 2 weeks ago that would have been presented at the Gypstick offsite. It's up on the YouTube Georgia ARES training channel for those interested in seeing that. Thank you.
Very good, Mark. And I meant to emphasize that everyone, we've done the detailed class on Winlink proficiency the week before, and it also is up. If you search Georgia spelled out ARES on YouTube, you can find our channel. And there's quite a bit of stuff up there, and we're going to organize it thematically, but there's quite a bit of training material on that site, and I highly recommend that you go there. Also on Groups.io, anybody that is involved in this Winlink proficiency needs to become a member of Georgia ARES, GAARES.io, groups.io. And there you can access all the information. I'm not going to take your time up now promoting that program, but we will in the future. And thank you so much for your time and attention. I will now stop the recording.